In Star Wars Episode 5, The Empire Strikes Back, Luke Skywalker crash lands on the planet of Dagobah while searching for Yoda to help him complete his training. When it is time to return to his friends, Yoda helps Luke by force lifting his X-Wing out of a swamp. We pose the question, how much force was needed to force lift his X-Wing off the planet of Dagobah? Our problem relates to Newton's 3 laws of motion. The first law, which is inertia, is relevant because the X-Wing is so large it will have more inertia than a smaller object, meaning it will require more force to lift. The second law gives us our equation for force, because acceleration times mass equals force. We need acceleration from the second law. The third law exposes a flaw in Star Wars. Because of equal and opposite reaction, Yoda would have had a large force against him while he lifted the X-Wing out of the swamp. To complete our problem, we must first find our givens. The mass of an X-Wing, after some research, we have discovered is about 5,443 kilograms, and the acceleration of a force push from Yoda is 1.40 meters per second squared. We start by showing that force applied on the y-axis and force of gravity are the only forces on the y-axis. Our equations show that the total force on the y-axis is equal to mass times acceleration on the y-axis, and mass times acceleration on the y-axis is equal to force applied on the y-axis minus force of friction. When we substitute our givens into the equation, we find that force applied on the y-axis minus 53,400 newtons is equal to 7,620 newtons. This leaves us with force applied on the y-axis is equal to 61,020 newtons, or 6.10 times 10 to the 4th newtons when you put it in scientific notation to get 3 sig figs.